Hello, everyone. This is Dr. Zach. So, this test is kind of a big deal. It's going to take a lot of effort on your part to really know your rules. So, I wanted to give you an extra opportunity to practice. So, spend 7 minutes on the lesson preview and then another 40 minutes. Afterwards, work for another 40 minutes to practice for your exam. So, turn the video off, work on the practice problems. Afterwards, you can check through some of your answers. Did you turn off the video yet? How about now? Is it off now? Turn off the video. Come on, turn it off, do the practice. Okay, classic arctan problem for question A. Make certain that you know your unit circle trig. Question B, long division, polynomial long division, and then you want to integrate. Once again, know what the new material for Unit 10 is and different ways that I can ask you to apply that new material. All right, so at first we want to make certain that you've added your initial value of 3 and integrated from 0 to 4. When you're finished, your volume will be measured in gallons. Now, the first part was no calculator. Question B, done very similarly, except this time we set it equal to 10 and solve for x. Now, when you solve for x, you're going to have to rewrite your problem as an arc sine again and then solve that for x. For question C, now I believe this is actually valve B, your total rate of. So if we're looking for rate of change, we want the amount of water going in, and then we're going to subtract the amount of water coming out. And now you are allowed to use your calculator. So if we're looking for the average amount of water, remember we want to put the volume equation in the problem, not V prime of T. I've calculated that to be equal to 6.040 gallons is the average rate. Question B, we want to know when the average rate is equal to the average amount of water. So for that one, we can take the amount equation and set it equal to 6.040. Question D, we're looking for average rate of change of the volume. So that is slope of a secant line once again. And then for question E, we want to know when the slope of the secant line is equal to your derivative. And our last two questions, we're looking for the derivative at 5.828 and the second derivative. Just read carefully to figure out which one you're being asked for. So check this problem out. You got to verify that you had a general solution. Then you got to determine the particular solution. You could actually do part B without part A. When we're looking for the average value of a function, don't forget, this was a calculator problem to help yourself out. And then we wanted to approximate C to the nearest 0.001. Now, I wrote X. I think that's a mistake on my part. They should say C for this problem. C equals. Now, for our last part of the problem, did you remember how to find cross-sectional volume? So the height was going from our curve -5, and since they were squares, you had to square that height. Question number 4, fabulous little problem. First, part A, you had to write the equation of a tangent line. And using the derivative that was given to you, you were able to find the slope. Once you have the slope and substitute in your points, 0 with 200, you're able to estimate the population of the deer. For question B, show that the second derivative is equal to that expression. So when you find the second derivative, you'll notice that you have negative dp dt, and then substitute. You are ready to begin the next part of the question. For part C, is your approximation an overestimate or an underestimate? So what you proved in part B is that the second derivative is less than 0 for all of the populations less than 1,200. Now, since it's less than 0, your function is concave down, which means that your tangent line is above the curve. So you have an overestimate. How fast is the deer population changing is actually asking you about the second derivative when t equals 10. Then you need to use separation of variables in order to rewrite the actual function. From here, you now need to know the definition for average rate of change and then how to find the average deer population. So lots of different definitions in here and separation of variables. This is a fabulous problem to practice for you. So for your first problem, did you remember that logarithmic differentiation is the way to begin this problem whenever you have variable to a variable expression? Also, you have a nice product rule that needs to be taken care of. Then when you rewrite your problem, you will replace the y on to find that final answer. Question B, do you know your rules for your derivatives? And question C, one more reminder of how to find the derivative of an inverse function. So the lesson follow-up for today is an opportunity to complete that optional review. That's it for today's lesson. Have a wonderful day.